Yes. Okay, we're ready. Now, we're going to do one more using my water reaction. Remember I said I was going to throw it into the fire. We're going to throw it into the fire here next with the practice problem. So I want to do one more before I get to this. We need lots of practice. Stoichiometry is, for some people, hard. Some people don't find it so hard, but some people find it difficult. So we got to practice, practice, practice. Okay, so here's one that's not on that sheet using my water. Okay, remember, mole ratio is moles over moles, and I erased it, but remember this, it's really important. Rockets, red glare, bursting in air every single time. Bells and or whistles should be going off in your head when you see moles appear on the bottom of a fraction in dimensional analysis. Okay, diving in, here we go. Try this problem. Okay, given 575 grams of hydrogen, how many, so I'll put question mark, how many moles of water could I produce? How much could I make? So we have 575 grams of hydrogen, and I need to figure out how many moles of water I could get from that hydrogen. Look at this. It's grams to moles. How many steps? Come on, come on, come on, come on, come on. One, right? No. That's moles to moles. This is grams to moles. 2 steps. Moles to grams or grams to moles, that's why I have the arrow going backwards, is going to be a 2-step problem. Now I could have said 575 moles of hydrogen. How many grams of water would that make? Okay, that's still a 2-step because moles to grams or grams to moles. 2 steps. Okay, why is 2 steps? Let's do it. Find out. 575 grams of hydrogen. Write that down. That's what you have. 575 grams of hydrogen. Of course, what do you do next? Multiply, divide. Grams of hydrogen. Grams of hydrogen. Okay, now, grams is not moles. So is this going to be a mole ratio? No, because a mole ratio is moles on the bottom for the first time, and then we'll put moles on top. This is grams on the bottom, not a mole ratio. Moving on. What are you going to have to go to? Remember last week when we talked about the second most important stuff, stoichiometry. The most important is grams to moles, moles to grams. You have to go from grams to moles. There's no other way to go. If you're at grams, remember grams was Boston, and then Chicago and San Diego. Boston, grams, you have nowhere to go except to Chicago. It's the only place you can go. You got to go to moles. So moles of hydrogen. Of course, it's grams of the same thing to the moles of the same thing. We're not going to shift here. Our gear shifting, changing substances occurs in the mole ratio. This is just a gram to mole conversion for the hydrogen. Okay, now what do we put next to the mole? 1. That's where the 1 goes. Wait, I thought it came from the balanced reaction you were harping about last video. No. In a mole ratio, we use the coefficients in the mole ratio. But when it's grams to moles, just like we have been doing, 1 goes next to the mole. All right, grams of H2. Be careful of that. Hydrogen is 1, but there is H2, so it's 2 grams. All right, that gets rid of my grams of hydrogen. It leaves me with moles of hydrogen. Now, moles of hydrogen is not what I'm trying to find. I'm trying to find moles of water. So that means you're not done. That's why we need 2 steps. We need another step. We have to keep going. Keep going. Okay. Now, what do you put on the bottom? Whatever's on the top. Ding, 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 ding. Those are rockets, red glare bursting in air. Okay, now you have moles on the bottom for the first time in this calculation, in this conversion. That is a mole ratio. Mole ratio. Now you know that if moles is on the bottom, and could you have a mole ratio, then I have to put moles on the top. Moles on the top. Moles of what? Moles of whatever you want. Now, if you want to solve the problem, put water. Moles of water. That's what we're trying to find. Okay. But 1's here, right? Just like in the last part. No. Really? No. This is moles to grams, we put a 1. This is a mole ratio. Well, there could be 1s. They could be. We have to go to the balanced reaction to see. Okay, moles of hydrogen. Coefficient is a 2. Moles of water. The coefficient is a 2. Not 1s. Now, it actually reduces down to 1, but they weren't 1s. So this is going to actually cancel out. So the math is going to come out to be, goes away. This actually is going to cancel out moles of hydrogen, leave me with moles of water, which is what I'm trying to find. So 575 divided by 2, that just does nothing. So I'll get, see if I can do this, 237.5. Okay, did I do that right? 237, that's at 60, that's 15, yeah, I did that right. So 237.5 moles of H2O. Some of you are saying you're harping on those significant digits, so let's round this. 1, 2, 3, 1, 2, 3, round that. So 238 moles of water. Okay, there it is. There it is. There it is. There it is. Stop it. Stop it. Okay, there it is. Okay, so that was a 2-stepper. Of course, we can do a 3-stepper. I'm going to do another one. I keep threatening you with this one. I'm gonna. Okay, I am going to do that one, but I want to do one more. More practice, the better. Here's the, okay. Okay, check this out. Check it out. Check it out. Let's say that you have 808 grams of water. How much oxygen, how many grams, question mark grams of oxygen must have been used to produce the 808 grams of water? Okay, here, let's see what we got going on here. This problem actually is giving you the product, and we have to predict how much reactant was used. So that's actually going the other way. Typically, stoichiometry problems don't do that, but they can, and it's okay. We don't do anything different. We have a certain amount of something, and we have to calculate the certain amount of something else. It doesn't matter if it's a product or a reactant. It doesn't change anything. The other thing is, too, is grams and grams. 3-stepper. You should see my feet. I'm going like 50,000 miles an hour. Good moves. Okay. All right, so write down what you know you have. 808 grams of water. Multiply, divide. Grams of water has to go on the bottom. Grams to moles. Grams to moles. And it has to be moles of water. Okay, grams of moles, you got to stay consistent there. 1 goes next to the mole here. It's a mole to gram conversion. Grams of water is 18 when we add up the 2 hydrogens and the oxygen. Okay, that cancels out grams of water. Now that gives me moles of water. Not even close to what I want. I want grams of oxygen, so I'm not done. Another step. Multiply, divide. Okay, I'm running out of room here. All right, so moles of H2O goes on the bottom. On the bottom, moles. Bing, 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 bing. We have a winner. Okay, that is a mole ratio. When you have moles on the bottom for the first time in a problem, it's a mole ratio. So you are going to need moles on the top. Moles of what? Moles of what? Whatever it is you're trying to find. In this case, we were given the water, we're trying to find the oxygen. Put that up there. Moles of the O2. Oh, ones go here, right? No, no. Use the balanced reaction to fill in those numbers. Now, with the oxygen, a 1 goes there. See, I told you it was a 1. But it's a 1 only because there's a 1 here. With the water, we put the 2. It cancels out my moles of water, leaving me with moles of oxygen. Now, if I were just trying to find moles of oxygen, I'd be set up and ready to go. Crank it out, get the answer. But we're not. We want to get grams of oxygen. We need one more step. So one more. Uno más, muchachos. Moles of oxygen go on the bottom. Moles of oxygen go on the bottom. Oh, mole ratio on the bottom. We have a mole ratio. Yay! No. I thought I was getting this. No, because we've used a mole ratio already. The first time when doing our calculations that moles appears in the bottom, That's the mole ratio, and we used it already. All right, mole ratio is always used in stoichiometry one time. So we've used it. Now I have another mole ratio. Even though moles is on the bottom here, you are not going to put moles on the top. If you don't put moles on the top, what do you have to put on the top? It's a three-step. It's grams to grams. You want to put grams. You can go from moles to grams. We can do that. So I'm going to go from moles to grams. I'm trying to find grams of the oxygen. Now the 1 goes next to the mole, not because there's a coefficient 1 here, because we're doing a mole to gram conversion. That's why the 1 goes there. Okay, it's coincidence that it happens to be a 1 here and here. Okay, so go ahead and add up stuff from the periodic table. You've got 2 oxygens, so be careful, 32. And we're all set up. You do this on an exam for me. You've got yourself 4 out of 5 points, and that's pretty good. Let's just not mess up the math, and we'll get our 1 extra point. Okay, so we're going to have to do this one out. I'm not going to do this in my head. No, I'm not going to. Okay, 808. So anything on top gets multiplied, anything on the bottom gets divided into. And you can do it in any multiple ways that you want. It doesn't matter, it's multiple ways. 808 times 32. I'm going to do the stuff on top first. Divided by 18. I like to get an enter at that point and then hit it again. Divide by 2. And we get 718.2. So 3 sig digs, so that would be 718 grams of oxygen. Boom! All right. We did it. We did a 1, a 2, and a 3-stepper. I think you're ready. I think you're ready for the big time. Jump into that frying pan. You can do this. I have faith in you. You're pretty much the favorite class that I have in chemistry 1 right now. Yeah, so that's our answer, 3 steps. Did it, done it, doing it tomorrow. Woohoo! All right. Now, okay, 1 step, 2 steps. I'm going to get rid of this, okay? I'm going to move this out of the way. I think if you don't have that by now, doggone it, go back and rewatch. Write it down. Do it. Do it. Do it now. All right, it's getting late, and I'm running out of juice here. Got to try to get this bad Larry done. Okay. Stoichiometry practice problems. I actually am really low on battery power here. If I try this one, I'm probably going to run out of battery power like in the middle of it, and I'm going to go, man, I don't want to do that right now. So I'm going to stop this video, and then, as I keep threatening you, we are going to do these. We will. It's kind of like, man, do it. Just get it over with, man. You're threatening. I can't say it. Okay, so we will, next video, do